Hello guys, and welcome back to Introduction to Number Theory. This video is the beginning of our study of continued fractions. What is a continued fraction? Well, we start from a number we call a0, then plus 1 over something that starts from a number we call a1 plus 1 over and so on, a2 plus 1 over a3, and I really don't know when to stop, so I'll just write down plus and dots. Before we find out something about values of such expressions, we will study expressions themselves. For instance, what if we take a continued fraction with only two floors, say a0 and a1? Well, we will have a0 plus 1 over a1, and we simply think that there is nothing after a1. So we can turn this into a0, a1 plus 1 over a1. And what if we take three floors, a0, a1, and a2, and simply throw out everything after a2? We will have a0 plus 1 over a1 plus 1 over a2, and we can transform this into, well, we have an intermediate step where we transform the denominator of the fraction into just a fraction, a1, a2 plus 1 over a2. And then we can turn this whole expression into just one fraction. In the enumerator, we will have a0, a1, a2 plus a0, and also plus a2 over, well, I write it here, a1, a2 plus 1. So we come across some polynomials in variables a0, a1, a2, and so on. And we understand that if we have a finite continued fraction, which means that it ends at some moment, then it can be transformed into a more simple fraction where denominator and enumerator are just polynomials in these variables. So now we will study more deeply these polynomials we come across here. This one and also this one. Well, all these polynomials are called continuants. So let me give a definition of a continuant that is quite far from continued fractions. So we'll have a separate definition, and from this definition we will derive all the properties and also the connection between continuants and continued fractions. A continuant, denoted as k with index n of variables, I'll say x1, x2, and so on, xn, is indeed a polynomial. All its coefficients will be equal to 1, and it is gained from a product, an expression, x1 multiplied by x2 multiplied by x3, x4, and so on multiplied by xn. So we take this expression and then throw out pairs of x's in all possible ways. So if we see a pair of x's, we can throw it out and then write down the expression we get. And then we can throw out some other pair and other pair. And we write down all these expressions that are gained from the big product by throwing out pairs of x's. Well, I believe it's not very clear by this moment. So let's consider an example. For instance, let's calculate the continuant k5 of fx1, x2, x3, x4, and x5. So we need to write down the expression x1 multiplied by x2 multiplied by x4 and multiplied by x5. And over here we will just write down all the expressions that will be included into this polynomial. Well, for instance, we can throw out 0 pairs, which means that we need to take all this expression as a first summand. Plus. Well, now we can throw out, for instance, the first pair, x1 and x2, and write down what is left, x3, x4, x5 plus. Now we can throw out, well, we can return this pair x1, x2 back into the product and say throw out x3, x4. So this is plus x1, x2, x5 plus, let me continue here, plus. Now return x3 and x4 and say throw out x2, x3. So plus x1, x4, x5, and we're not done yet. So we return this pair and throw out, well, x4, x5. So we have x1, x2, and x3. And I believe we're done throwing out exactly one pair, because this pair is, if we throw out one pair, then this pair could be this one, or this one, or this one, or this one. So 4 such summands we gain if we throw out one pair. But we can also throw out 2 pairs. And this will give us, for instance, if we throw out the first 2 pairs and leave only x5, so plus x5. Or we can throw out, for instance, the first pair and the last pair. So x3 is left. And also we can throw out everything but x1. So x1 is left. And just let me see, 1, 2, 3, 4, 5, 6, 7, 8. That's it. So this is a continuant of order 5 and also of degree 5 in variables x1, x2, x3, and so on, x5. Further on, we will study some properties of these polynomials, so stay tuned.